Good evening, everyone. My name is Mano. I'm here with my team members. Today, we are excited to present on CockroachDB, a powerful and resilient database management system. Did you know that CockroachDB is designed to survive disasters much like the cockroach itself named after? This unique features makes it an excellent choice for business that needs reliable and scalable data solution. In our presentation, we will be covering the key concept of CockroachDB, including its implementation, architecture, data modeling and design, and use cases analysis. By the end, you will have a solid understanding of why CockroachDB is a game changer in the world of database. Let's dive into the core feature of CockroachDB. CockroachDB is distributed SQL database, which means it can spread data across multiple nodes, ensuring high scalability and availability and horizontal scalability. One of the standout feature of CockroachDB is that open source and cloud native. Being an open source means it's freely available for anyone to use and modify. As a cloud native solution, it builds to leverage a cloud environment, providing flexibility and scalability. Another key advantage is compatibility with PostgreSQL. This means it can integrate seamlessly with existing applications that use Postgre, making migration and integration process much simpler. Now I hand it over to Carlton. He will explain about the implementation of CockroachDB.
Hello, everyone. My name is Carlton McDaniel, and I'm a member of Group 7, and I'm going to give a demo on CockroachDB's installation and technical implementation. And I do want to mention that the installation process was pretty straightforward, and CockroachDB has instructions on both Windows systems and Linux-based systems, so that was extremely helpful. And from there, let's dive in. And I do want to mention that I have the commands on the side for the sake of time of this presentation. So for this first command, I am installing CockroachDB using curl. Let's give that a few seconds. Perfect. And next, I'm going to extract. For this next command, I am installing CockroachDB CLI into the system path, so that way I can access it in other directories as well. And I'm just going to run a cockroach version here to ensure that the install was done properly. Okay, perfect. Next, I am making a directory for the SSL certs. And now I'm going to generate a SSL certificate. Perfect. And this next command here will create a certificate authority to actually sign the certs. Perfect. This next command will create a secure certificate for the CockroachDB node. Okay, perfect. So throughout those chunks of code that installed CockroachDB as well as secured it with SSL certificates. And next, I'm going to start the CockroachDB as a single node. Okay, so let's run this command here. Let's see if we can start that. Perfect. And then this next command here will connect to the secure shell of CockroachDB. Perfect. So we are connected as root here. And let's just do a show databases to see what we have here. Default DB, Postgres, and system. Okay, so I'm just going to create a test database. Create database test. And ensure that that runs properly. And we're going to do a show databases again there. And there we have it. We have our test database there. And that is all I have. I hope you enjoy the rest of our presentation. Thank you.
Thank you, Carlton. Let's take a look at the architecture overview of CockroachDB. CockroachDB was designed to create a source available database that is both scalable and consistent. Developers often have a question about how we have achieved this scalability and consistency. This guide aims to detail the inner working of the CockroachDB process to provide a clear explanation. Next, we can take a look at the layers of CockroachDB. We have like 5 layers, which is like SQL, transactional key values, distribution, replications, and store the data. Next, we'll take a look at the key architecture terms. We have like eight key architecture structures: cluster, node, range, replica, leaseholder, raft, consensus protocol, raft log, and raft leader. Next, we can talk about the security consideration while installing the CockroachDB. CockroachDB security focuses on authentication, authorization, and data protection through TLS encryptions and primary key infrastructure and role-based access control, ensuring secure data storage and access. There are like five steps we have to make as a consideration: transport security, authentication and authorization, network security, database security, and compliance and best practices. Next, we can take a look at the performance of optimization strategies. There are like 4 performances: query optimization, load balancing replications, storage and scaling, caching, and connection pooling. Now let me hand over to Joyce.
Thank you, Mana. I'm going to be talking about the data modeling and design for CockroachDB. As Mana mentioned, CockroachDB is a distributed SQL database built on a key value store. This means that it automatically replicates and balances data across multiple nodes. This architecture ensures high availability, prevents downtime, and minimizes data loss. Next slide, please. As the name suggests, CockroachDB was inspired by the resilience of roaches adapting and surviving in tough conditions. This resilience is what makes CockroachDB stands out. It's able to survive hardware failures, data outages with little to minimal intervention. Next slide, please. When it comes to schema, we look at 2 things. We look at design principles and implementation. Design principles asks the question, why do we choose CockroachDB? And implementation refers to the how we structure and optimize schema for efficiency. Next slide, please. A good schema in CockroachDB follows key practices. We have well-defined primary key, normalizing data, but limiting joins, optimizing indexing, sharding, and data distribution. We also have, next slide, please, geo-partitioning for performance, multi-tenant design, and schema evolution. Next slide, please. For pointers, we added differences between CockroachDB versus traditional relational databases. We do have multiple features on how they're separate. Next slide, please. We also added CockroachDB versus NoSQL databases and their differences as well. Next slide, please. To scale efficiently using CockroachDB, there are multiple ways to do that. You can add more nodes to distribute the load efficiently instead of upgrading a single server. We also have leveraging geo-partitioning, optimizing indexing, patch transactions, and deploying at least 3 nodes to minimize crashes. This ensures high availability, low latency, and resilience against failures. I'm going to pass it on to Senad.
Hi all, let's now start operational analysis by focusing on the core database operations, CRUD, which stands for create, read, update, and delete. These operations represent the foundation of any database interaction. In the next slide, we will walk through each of these operations using CockroachDB. Here we have created a database called bank and created a few tables, customers, branches, and accounts, and so on. We have inserted a few records into the tables that we have created earlier, and then we have performed a select star from one of the tables. And again, we have done update and delete for one of the table. So pretty much we can see that all the syntaxes are same as traditional SQL. So let's move on to query optimization techniques. Beyond basic operations, CockroachDB also supports performance optimization. We will now walk through a few techniques, starting with indexing and partitioning. CockroachDB supports indexing to enhance query performance similar to traditional databases. We have created few indexes. You can see the creating index syntax here. And to handle distributed data more efficiently, we use table partitioning. This enhances performance for region-specific queries, especially in geographically distributed systems. Unlike many traditional databases, CockroachDB allows table partitioning to optimize data distribution and query efficiency, especially for geographically distributed data. Here you can also see that we have partitioned the values based on the countries. This is a sample query. To understand and improve query performance, we use the explain analyze statement. This tool allows me to examine query execution plans and identify bottlenecks such as inefficient scans or missing indexes. Here you can see the explain analyze syntax, and this allows us to know certain things which can help us examine the query execution plan. Next, we'll move on to transaction management. Transaction management is critical for maintaining consistency in a distributed database. CockroachDB has a distributed architecture built from the ground up as a distributed SQL database, allowing horizontal scaling across multiple nodes. Data is automatically partitioned and replicated across nodes, enhancing scalability and resilience. Utilizes the raft consensus algorithm to achieve agreement among nodes, ensuring that transactions are committed consistently across the stars. It is designed to survive various infrastructure failures, providing high levels of resilience and availability. Automatic rebalancing and repair mechanisms maintain data integrity and availability without manual intervention. CockroachDB also supports ACID transactions and uses MVCC, multi-version concurrency control, for consistency. It defaults to serializable isolation level, which is the highest level, ensuring no anomalies occur during concurrent transactions. In the event of transaction conflicts, CockroachDB can automatically retry transactions, reducing the need for manual intervention, a feature not commonly found in traditional databases. This is the sample of a transaction. You can see. So yeah, we can use save point in a transaction. If any failure occurs midway, CockroachDB retries the transaction transparently. Monitoring. CockroachDB provides built-in tools and integrates with external systems for performance analysis. The built-in DB console UI, which is present in the metrics here, the data of whatever queries we have run and the connections rate and the connection latency and everything. You have many other features which we can explore in CockroachDB. CockroachDB supports integration with Prometheus and Grafana, giving engineers full visibility into metrics like CPU usage, query latency, and disk activity. Now we'll discuss about the three key metrics. Query latency measures the execution time of individual queries. This is crucial for assessing responsiveness. Queries per second shows database throughput, indicating how many queries are handled per second. Node health metrics includes CPU usage, memory consumption, and disk I/O, essential for maintaining optimal performance. Provides insights into system resource usage. So we have two queries, show queries and show sessions, which shows the running queries and shows the running sessions. So together, these tools give you immediate insights into how resources are used and help you take proactive steps to maintain system health. So for query performance, the best practices could be we can use batch processing for bulk inserts, avoid full table scans, use indexes efficiently, optimize joins and aggregations for large data sets, use show jobs to monitor background tasks. When you run show jobs, you can see there are a list of background tasks that appear, which will help you optimize the performance. Thank you.
Some optimal use cases. If you've ever paid a bill online, ordered an item from your favorite e-commerce site, or navigated a series of security steps to verify your identity, then you've interacted with CockroachDB. Any user counts and metadata, identity access management, payments, and order and inventory management. These are all use cases that are organized into 3 buckets. Use cases serving people, money, and things. Next slide, please. And now we have pros and cons. Pros, you have distributed SQL, survivability, consistency, and compatibility. I'm going to highlight consistency. CockroachDB offers strong consistency, unlike eventual consistency provided by many NoSQL systems. And then cons, we have performance, operational complexity, and limited SQL coverage. And the cons, I'm going to highlight operational complexity. It is straightforward to operate, but the consistent system involves tackling complexities inherent in distributed computing. Next slide, please. And I will pass it over to Taylor.
Howdy, y'all. We're going to talk about some enterprise level use cases you might use CockroachDB in. First up's multiplayer gaming or anything similar to it. CockroachDB natively comes out of the box with automated horizontal scaling and load balancing. And what that means is you'll have consistent throughput for all your concurrent users, regardless of how usership spikes throughout the day, which is definitely useful to have. And geographically mindful local clustering. It's really easy to co-locate the data with the user, overall improving performance for everybody across the globe. Financial services and banking, CockroachDB is fully ACID compliant, ensuring that transactions are accurate and account data is always consistent and up to date. And geo-partitioning for regulatory compliance, that co-location of the data makes it really easy to comply with any local regulations you might have to deal with. E-commerce. Regionally connected clusters paint an overall picture of your global inventory. So no single node has your entire data set, but together they paint a picture of what your global inventory looks like. And then strict consistency guarantees that all those inventory numbers are correct and accurate. And then high scalability and fast follower reads can serve your customers up-to-date recommendations, which is usually a super read heavy process. Slide, please. Additionally, we've got healthcare. That full ACID compliance guarantees accuracy and availability of your patient records. That geo-partitioning reduces latency for your users and maintains compliance to the regional regulations wherever your users happen to be. And then CockroachDB supports native encryption in transit and at rest of all the data, which is required per HIPAA and stuff like GDPR regulation. And lastly, fraud detection, which is another super read heavy process. You can run your analysis of your global data feeds in parallel across nodes to distribute the overhead. You can also make use of follower reads, once again, to quickly detect known signatures of fraud or intrusion in your system or anything like that. And you can leverage native change data capture technology for real-time analytics to your downstream software. Slide, please. We've got some compare and contrast to other solutions you might be familiar with. MySQL, the big perk there is very simple. Most people are familiar with it. It's very proliferated, but it's a little limited. It's usually a primary and secondary scheme. It's not highly distributed, where CockroachDB out of the box is purpose-built to be very distributed, many nodes, and super elastic. Slide, please. PostgreSQL, it really illustrates the antithesis, a very monolithic single node structure, if that's what you're looking for. It's very good in vertical scaling if you want to build resources on your one workhorse system, whereas Cockroach is very much not, very highly distributed, very automated. Slide, please. And lastly, we've got Cassandra, which is semi-distributed. You can horizontally scale it, but it's highly manual, but you can do it, where Cockroach is highly automated. It's a little more complex than CockroachDB, which is already more complex than SQL. Uses its own proprietary language that lacks some common SQL tools you may be familiar with and want. And then ACID compliance is incomplete in Cassandra. It has some, it's missing some, whereas CockroachDB is fully ACID compliant. And then that also ties into regulatory compliance. Cassandra is limited. It encrypts the data at rest only, whereas Cockroach encrypts it at rest and in transit. It provides audit logging and role-based access control for super fine-tuned controls of who touches what data. Slide, please. And these are our references, and that concludes our brief on CockroachDB.
Thank you all.